All right, so we are going to talk about quadratics. I know when we initially got into this in my class that this was a little bit iffy, so I wanted to make sure that we took a look at some things that were going on here. If time permits, we'll take a look at IXL K1 as well. Although if you understand this one, I think the other is going to be okay. So the initial thing we needed to know is that we are dealing with quadratics. So what is a quadratic function? So we said in the past we've had linear functions or linear equations even, where when we graph those, we get a straight line. A quadratic has an extra term compared to like slope-intercept form or something like that, that causes it to, instead of being a straight line, be something that we call a parabola, which is basically almost like a U shape. So I mentioned slope-intercept form was kind of the general outline of a line, a straight line. For a quadratic, what we're going to see is, if we're going to go with an equation, you would think y equals, and we could have like a, oops, let's make that a little bit better. We could have like ax squared. So this is kind of the new part. Remember, that's times in the middle, multiplication plus bx plus c. So if you just look at the bx plus c, that kind of looks like the end of slope-intercept form, but now we have this term in the front that has an exponent of 2. That's what causes us to get a graph that is no longer linear. So depending on what it's asking for in each question, like this one, the y-intercept, we're going to go through different steps to reach an answer. So let's kind of work through a couple of them and let's hit on the different things we might see. So the first one's a y-intercept. That's probably the easiest one. We're going to take whatever our given equation is. So for us, that's this y equals x squared. And we're going to plug in 0 for any of the x's in that. So let's wipe the screen real quick. You guys saw a second ago that I had an a term, a b, and a c, and they only give me x squared. What that actually means, it's beneficial to us, but you got to know this, is after an x squared, that's the same as if we had a 0x and a plus 0, which is not going to really affect us here. It's going to make the whole thing pretty simple. So when I'm finding the y-intercept, the only thing that's going to really have any effect is I'm plugging in 0 here. I technically would plug 0 into that as well, but it's already 0, so nothing really changes. So if I think through this, 0 times itself, because it's squared, is 0, plus 0, plus 0. That tells me my entire thing is going to be 0. Since it wants a y-intercept, I know that a y-intercept is just a point, so I only need to, there's just a single value, so I know I'm only going to put one number. Awesome. Okay, so we're going to find an equation this time, so that's a little different. This is important, and this is what throws a lot of people off. The axis of symmetry, and there's my initial equation. For this one, I have a formula that I'm going to follow for axis of symmetry. X equals negative b divided by 2 times a. So when we get these parabolas, we said, let's put it over here. Let's go with green. They're going to be kind of like a U shape, which means somewhere down the middle of it, they're going to be symmetric over themselves. That's the axis of symmetry, wherever that x value is. So like right here in this case. Because it wants an equation for this one, I'm going to put x equals, and then whatever value I get here. So let's go ahead and do that. I'm going to have x equals negative. My b value is the one that's next to the x term, so I'm going to have a negative of a negative 2 because of that minus sign. On the bottom, I'm going to have 2 times, if I don't see anything in front of here, but I still have the term, it's a 1. So that means on top, a negative and a negative is going to give me a positive 2, and 2 times 1 on the bottom is also 2. Anything over itself is going to give me 1. So because it's an equation, that's why I have the x equals there, and I'm going to put x equals 1. Awesome. All right, let's clear off again. It's another axis of symmetry one. Let's go ahead and do this as well. My a value doesn't show me, but that's going to be a 1. My b is going to be a 6. So when I plug in to this formula here, I'm going to have x equals negative 6, because it was a positive 6 to begin with, 2 times 1 on bottom. Negative 6 divided by, that's just going to be 2, would give me negative 3. Again, this is important. It wants an equation. So in my answer, to make it an equation, I have to have something equals something. So we say x equals and then negative 3. All right, a y-intercept. So for this one, anytime I see an x, this is like the first example we did, we plug in a 0. So when I do that here, I'm going to have y equals 0 squared minus 6. 0 squared is 0 minus 6. It's going to give me negative 6. This one does not ask for an equation, so I'm just going to type that number in. There we go. The minimum value. So this is a little different. So if we go back to thinking about what a parabola looks like, some U shape, there's going to be some point that's called a vertex. That's the very bottom or the very top if we had a flipped upside down one. If it asks for a vertex, it would ask for both the x and the y values of this coordinate. The minimum or maximum is just the second number, just the y value. So how far up or down, in this case, we reach on our graph. So to do that, our first step is to find the axis of symmetry, kind of like what we were doing before. But then we're going to use that for something else. In this one, they give me an a, which would be 1 here, but they don't give me anything else, so b is going to be 0. So if I plug in here, and I get something like this, negative 0, that's just 0. 0 divided by any other number is just going to be 0. But that's not my answer. It doesn't ask for axis of symmetry. So what I need to do is take that number I found, and it gets plugged right back in for the x value there. So now I have y equals 0 squared. But this one's pretty nice to figure out. 0 squared is just 0. So it's kind of a multi-step process right there. Okay, this is what I was talking about a second ago. Vertex, it wants both the x and the y of that coordinate. So the x is going to be what we just did, where we're going to find axis of symmetry. In this one, I'm going to have x equals negative. Be careful here. A lot of people would think that the 4, just because it comes next, is the b value, but we know that if we think back to our initial form for a quadratic, the b term has an x next to it. The c term doesn't. So they actually give us a c term. They don't give us the b term at all, which means it's 0. So if I go back and I'm plugging in, I'm going to have negative 0 over 2 times, it's going to be 1 again for this one. We know that works out to 0 from the last problem. Since it wants the entire vertex, that's going to go in my first blank. That's the x portion of the coordinate. I'm going to plug that back in now. 0 squared is 0, plus 4 is 4. So now we give both pieces there. That idea of skipping from A to C, if that's something that you can grasp, that's kind of showing that you have great understanding of what's going on here. All right, let's take a look at this one. The vertex of the parabola. So same idea. X equals negative b over 2a. So I'm going to have negative 4 for this one, divided by 2 times 1. Negative 4 over 2 is going to be negative 2. So that's my first one. Remember, you can slow down and calculate this if need be. I was going a little quick there. But then I take this and I plug it back in anytime I see an x. So I'm going to have negative 2, I'd put that in parentheses even, squared, plus 4 times negative 2, then plus 1/2. I'm going to use my calculator for this. I'd like to put the negative 2 in parentheses just to be safe. That way the calculator includes the negative, plus 4 times negative 2 plus 1 divided by 2, or 1/2. Negative 3.5 is what the calculator tells me. But if I change that into a fraction, that's negative 7 over 2. The reason I change it to a fraction is because it says, simplify both coordinates, write them as proper fractions, improper fractions, or integers. So the negative 2, everything else we've been given so far is an integer, but this falls under the fraction portion. All right, we've already done a minimum. I think we're good here. Let me jump ahead just to be safe, and then maybe we'll take a look at K1. Vertex, same thing. Oh, now we're in the 90s. Okay, same thing, just throwing fractions out there. Okay, let's go to K1 real quick. And we'll check out what we get here. Oops, I clicked on the wrong one. So see how it says equations, and then when we back up one, it says graph. For this one, we're picking out pieces, but we're given the picture, so that makes it a lot easier to deal with. For example, we had a small preview of what a vertex is. It's the point where it stops going one direction and comes back down. It's like the tip, like the highest high or the lowest low of your parabola shape, your U shape. So we know it's right here where you can see me clicking. What's the coordinate there? Well, this one's actually at the origin, so it's 0, 0. So you can tell after 1, this is going to be a little bit quicker. The y-intercept, we said that's wherever the x value is 0. So this is on the y-axis, so the x values are 0 here. We go down to where it crosses, that's down at negative 9. Okay, we have the coordinates of the vertex. Now it looks like it's shifted over. It's no longer on the origin. So if I count over, though, I'm going right 2. That's the x direction. And then up 1, 2, 3, 4, 5, 6. So my coordinate's 2, 6. Just got to be careful. X comes before y. The y-intercept, so I'm looking for where it crosses the y-axis. That's up here. Looks like 9 to me. Awesome. Maximum, so basically from looking at the picture, we can tell the highest it goes, so the max would be up here. So we just have to say, how high is that? That's why in the other IXL, we find just the y value of a max or a min. This one is at 8. It's 3 above 5. Axis of symmetry. Okay, so we know it's symmetric through a line that would be, here we can even draw it, like right down the middle here. Oh, that was bad. And I probably shouldn't pick the exact same color. Am I able to zoom in? Let's see. Yes, but I lose my color. Okay. Yeah, I think that's the best we're going to get, though. But right there, it would be symmetric. So I have to figure out what x value is that. So if I'm counting to the left, 1, 2, 3, 4. Remember, it wants an equation. So x equals negative 4. The reason it's x equals because all the x values on this line are the same. So a straight up and down line is going to be x equals rather than y equals. Okay, all cleared. Axis of symmetry. This one's nice if it's the same on one side of the y-axis as the other. It's just going to be the origin, where x equals 0. Let's see if we have anything else here. Minimum would be down here, so that's negative. That'd be -9. Anything different once we get up here? Maximum still 0. Okay, same idea. So we'll wrap up here. Hopefully this helps us finish up these two IXLs and kind of our start with quadratics.